UL certification for electric bikes or batteries. What is it? Why are people talking about it? Why are we seeing fancy little stickers that people are advertising comes on their bikes? Welcome back to the Area 13 podcast. If you're new, there are 123 episodes already recorded in audio-only format. But moving forward, you can now find these podcasts in video as well on both YouTube and Spotify. But let's jump right into the issue at hand. There's no question that lithium batteries can catch fire. We've heard about it before, whether it was from vape pens, it was hoverboards, it's electric cars. We know that if a lithium battery catches fire, it can be rather violent and explosive. However, we have tens and tens of thousands, hundreds of thousands of electric bikes being ridden around, and it's not really being talked about that much because, generally speaking, it's not an issue. Now, there have been some isolated cases, especially in densely populated areas, where this has become a problem. Now, New York City is the first area that has put in a rule not allowing e-bikes to be sold if they are not UL certified. So I want to answer, what does that mean? And honestly, I had to really dig into this and look into it for myself, both as an e-bike manufacturer and reseller of other brands. I have to look to the future and see, is this something that's going to be required nationwide? Is it something we need to be safe? And those that know me know I'm all about being very safe, very cautious with the electric bikes that we sell, but I also like to have fun. I'm not afraid to overpower things, push some things to the limit, but when it comes to safety, that's kind of where I have to draw the line. Now, there are two UL certifications. I'm only going to cover one of them in detail because, honestly, one of them is still very confusing. There is a certification for basically the entire bike. So you can have the entire electric bike certified, or you can have just the battery certified, which I think is the main issue here. And my understanding is that either one of those would satisfy the requirements, for example, for New York City. And my guess is moving forward, that's probably going to be the case for anywhere else that implements laws regarding UL certification for electric bikes. And the reason I say that is if your, say, motor isn't UL certified, it's not likely to cause a very dangerous or hazardous issue. If a battery is not made well and blows up, obviously that's a problem. So I want to cover the UL 2271 certification standard and what that really tests for. And before I say that, I just want to tell people that I've always advocated to buy quality batteries. Many people know to ask where cells are made, what manufacturer they come from, and we primarily try to stick to the name brands like Samsung, LG, Panasonic, because we know those are made well, and a well-made cell is going to last longer. It's going to be better for your pocket, and it's also going to be safer because cells becoming unmatched and different voltages is when problems start to happen. The other half of that I feel like many people miss, and I'm going to reiterate it here, is that the quality of the assembly is equally, if not more, important. If you have quality cells that are assembled poorly with bad wiring, with a BMS, that's the battery management system, that's not very good, it's not going to work well. It's not going to last long, and there's a higher probability that it could have a problem in the future. So my thoughts are always that if you see batteries, whether it's eBay, Amazon, and they are half the price of what everyone else is selling, there is a reason they are that cheap. Please don't go cheap on your batteries. Make sure you're getting them from a reputable source. Now, let's jump into the 10 basic things that you have to have a battery go through for a UL certification. Now, UL is Underwriter Laboratories. Basically, they oversee certifications for all sorts of electronic devices to make sure they are safe. So it makes perfect sense that this is happening. Is it going to happen nationwide? We really don't know, but I think it's best that we start to be informed about what it is. And as manufacturers and dealers of bikes, I think we need to start going this direction because either customers are going to request it or eventually it might be required everywhere. So the number one test is called thermal runaway. Let's imagine you have a battery pack on your e-bike, and there are 50 different cells actually in that pack to make up the entire battery. The number can vary depending on the voltage, the capacity, but we know that in most e-bike batteries, there's a bunch of little cells inside. They might be 18650 format. They might be these newer 21700. It might be something entirely different, but thermal runaway is when a single cell in that pack has an issue that causes it to overheat. So UL has a test to see if your battery can avoid thermal runaway, which is the fact that that single cell heats up so much and most likely catches fire that it actually catches cells next to it on fire that would have been otherwise perfectly fine. And basically you have this chain reaction where that cell then lights the next cell, and then that cell lights the next cell until the entire battery pack is engulfed and shooting out flames. So thermal runaway can be prevented in a few different ways. It can be prevented electronically. There could be something that basically shuts off that cell before it has a chance to overheat. It can be done in some mechanical sort of construction fashion where maybe the individual cells are separated and have heat protection barriers between them, so that way the heat cannot travel to the neighboring cells. But that's number one on the list. If we can take a cell, basically kill it, and it doesn't light the rest of the battery pack on fire, then that is a big step in the right direction. So that's what thermal runaway is, and that's just 1 out of 10 different things they test for. Number 2 is an overcharge test. So let's say you have 2 different e-bikes at home. One is a 36-volt bike, and one is a 48-volt bike, and they happen to use the same charge plug. This is a realistic scenario that could happen. If you take that 48-volt charger and plug it into a 36-volt battery, and it was allowed to charge, it would eventually die, most likely catch fire again. Now, we really don't want that to happen, obviously. And again, this is where there needs to be circuitry built into the battery so that cannot happen. If the battery sees that the charge voltage coming in is too high, then it has to stop that charge from occurring or shut the battery off. Now, that's something that's typically done in the BMS circuitry, and for obvious reasons, that's going to avoid another possible safety issue. On the opposite side, the battery needs to have an over-discharge safety function. So lithium batteries are very sensitive to stay within a particular voltage range. A single lithium-ion cell is about 3.7 volts. Fully charged, it's about 4.2 volts, and typically they're going to be run down to somewhere around 3 volts, maybe about 2.8 volts. But if you try and run that cell down to, say, 2 volts, which doesn't seem like that much further, when it goes to recharge again, that can cause issues with the internal chemistry of the battery and cause premature failure. So that BMS in the battery also needs to stop the battery from discharging too low. And likely you have experienced this before if you've ever gone on a long ride on your e-bike. The battery starts to get low, and all of a sudden your bike just shuts off. That is a safety feature built into a battery. The fourth thing is rather interesting. I don't have detailed specs on exactly how this test is done. I need to find more detail on this, but it is a crush test. Many bicycles are bought online these days. What if your bike gets crushed by another package? How much force can that battery withstand without short circuiting and having an issue. That is one of the tests. I don't know how much of a crush test they do. Do they just put like a little bit of force on the battery? Do they want this battery to like survive a truck driving over the top of it? I'm really not sure. I need to find more detail on that. But really what it comes down to is the battery can't easily break if there is some extra weight being placed on the battery itself. Next up on the list is an external short circuit test. Now, this makes a lot of sense to me because I've been working on bikes for many years, and I have seen some short circuits occur when a particular component fails, whether it's a motor controller, if it's a cradle even, maybe the motor itself. There are some unique scenarios where basically the battery can be shorted. So the positive and negative terminals are connected together. That's going to lead to a brief spark, and then typically there's going to be a fuse in the battery that blows when that happens. Now, whether it's a fuse, whether it's another circuit built into that BMS that shuts things off, UL certified batteries need to have a safety mechanism in place so that if those positive and negative terminals are crossed, the battery safely shuts off. Next up is an impact test. What if you are out on a mountain bike trail having fun and you crash your bike? Or let's say it's on a bike rack, you forgot to secure something on, and your bike falls off the rack. Obviously, we don't want either of those things to happen, but what happens when that battery impacts the ground? What happens if that battery hits a rock on the trail? What if you're pulling the battery out of your bike, you slip, and you drop the battery on the ground? How much of an impact can that battery take? That's one of the tests for UL certification to make sure your batteries are safe. And going along with that is also a vibration test. Let's say you're going down a gravel road that's real washboard and bumpy. Can your battery handle extended periods of vibration without screws coming loose, without wires coming loose, without connections welded onto those cells coming loose? There is a lot that goes into battery construction that we often don't look at or see. Those all need to be secure, and they need to last a long time because any one of those can lead to a short. There's also a water immersion test. Some of you might be thinking, well, does that mean UL batteries have to be waterproof? And the answer to that, I think, is no. They don't really have to be waterproof. They just have to be safe. So waterproof obviously would be ideal. If you could dunk your battery underwater, pull it out, and it works perfectly fine and is safe, that would obviously be awesome. And that's the direction we want to go with, I think, all e-bike batteries. But I think the testing procedure is just to make sure that if it's submerged in water, it's not going to fail in a catastrophic way. Now, water conducts electricity. Typically, if you dunk a battery in water, you're going to end up shorting the battery out. So to me, this is kind of like an external short test, but it's different because with that, they're probably connecting directly to the positive and negative terminals on the battery. With water, that short could occur anywhere realistically inside the battery. So it really has to be well protected, electrically speaking, or physically. Maybe the battery is constructed in a way that it is watertight and water cannot get in. But either way, that cannot cause a battery to catch fire, or else obviously the UL certification would not apply. There's also something called thermal cycling. So you have extreme temperatures. Batteries, particularly lithium batteries, do not like temperature extremes. They do not like to be charged when it's really cold. They don't like to be overheated. There is a balance there where they are happy and they work quite well. But what happens if you bring a battery down to 0 degrees and then heat it back up to 100 degrees and you do that repeatedly? Is the battery going to fail next time it charges? Is there a component in the battery that's going to break because it can't withstand the temperature fluctuations? With that kind of temperature change, things expand, they shrink? Could the case crack, cause a short somewhere? Could one of the wire connections come disconnected? Those are all things that are really going to be stressed when you're pushing those temperature limits to those extremes, not just the cells inside. And the last thing they test is called a forced discharge. Now, I assume what that means is they are drawing a lot more power than what the battery is intended for. So this is different from a short circuit. A short circuit is connect the positive and negative. That's going to basically discharge all of the battery at once if it was possible. There's always things that burn up or fuses that blow before that happens. But I think in a forced discharge, what they're doing is probably continually increasing the current on the discharge side of the battery until something fails, and making sure that it fails safely. Now, this could be as simple as an internal fuse on the discharge side. It could be some sort of breaker, I think, that could be reset, but cells have a maximum current limit. So we know based on the manufacturer of the cell and the configuration how much current a particular setup can put out. And most e-bike batteries, I would say, can probably actually handle a lot more current than what we use out of the individual cells. Realistically, our batteries are getting bigger, and with the maximum wattage limit in most states being 750 watts, we're not pushing them that hard, but they need to have some sort of safety measure in place to where that can't happen. Let's say a battery pack can realistically handle 50 amps of current, which is quite a bit. You know, an e-bike might only have a controller that pushes through 25 or 30 amps. It's never even going to get close to that limit. But what if some weird fluke thing happens and somehow something is trying to draw 100 amps, more than double what the battery is rated for? Well, those individual cells are going to heat up, they're going to get stressed, and eventually one of them is going to get too hot and it will fail, potentially leading to that thermal runaway problem. But if we have, again, a fuse or a circuit breaker or something built into the battery to where when it hits, say, 50 amps, it shuts off the battery, then that's really not going to be an issue. Most BMSs, the battery management systems built in, have a feature like this already. Now, the e-bike manufacturers don't typically tell you what that is because the bikes are set up with a given motor, with a given motor controller, and it's not something you typically need to know, but it is usually there. The difference with UL certification is that you have to take all of these different things we just talked about, implement them into your battery construction, and then you can't just meet their testing guidelines. A third party has to test your battery and verify that it can pass all of these tests. And only then is it deemed safe enough to have a UL certification. So this is a very official sticker that's going to go on a bike or on the battery itself that says this is UL certified to this specific standard. And as a consumer, then you can know that, oh, this battery is tested, so it should not be capable of having a thermal runaway. It should not be capable of an over discharge. This is going to be very safe. So I have really been researching a lot on battery safety, construction. What is it that's causing problems? And I think a lot of it is just poor quality construction, poor quality BMS, poor quality cells. I know in the early days, the hoverboard fiasco, as I'll call it, was one of those things where I think a lot of those were being shipped so cheaply that they didn't even have a BMS. And that's why we had so many fires. There were no protections put in place. So you're going to be seeing more of this. I certainly will be bringing it up again in the future. What I'm doing at Area 13, just so you guys know, is I am currently reaching out to all of our suppliers, our bike suppliers, our battery manufacturers, and I'm asking these questions about, is this battery UL certified? Is it something you're working on? And that's something we're going to keep inching closer to. There are some bikes on the market now that are already UL certified, but they are very, very limited. Last I checked, if you go look at most of the big name brand or even some of the biggest e-bike companies out there, they are not UL certified yet. I think Rad Power said they are working on it. Specialized, I believe, is not UL certified yet, but I'm sure they are working on it as well. But we do have some companies like Aventon, I think, that has already gotten it. Velotrick is another company. I just reviewed a bike from a company called New, and that battery is UL certified. So everybody, I think, to some degree is working on it. Whether or not it's going to be a requirement, I don't honestly know, but I think what we should do is make sure our batteries are safe. And if this is the direction we have to go, then this is the way the industry is going to go. So now you know basically what that means, what to look for, and hopefully with all of this knowledge, we can avoid e-bike fires altogether. Thanks for listening or watching. Once again, if you're new, this is the Area 13 podcast. There are 123 episodes already out. Go check those out on your favorite podcasting platform, and we'll talk again soon.